Hello, Arat. Hello.
DJ, your voice is
Hello, can you hear me?
a little. I just hear the end. Can you
Okay.
repeat? Oh, now I can.
How about now? Can you hear me well, Arat?
Yes.
Okay. Okay, Arat, why I can't see you?
Can you see
Yeah,
me?
Arat, you are the only one here. Show me your face.
Is
When
it
you are,
always like this?
yeah, I can see you now, much better. When you are tired or bored, let me just know. We can have some break, and after that we'll continue. Okay?
No.
Because right now in this group, you are the only one student, and that's why I want to see your face. Otherwise,
Till
just keep. Sorry?
am I gonna be alone till the end?
I don't know. I don't know. We will see. So you don't want to be alone?
Doesn't really matter
Yeah, we will
because it's
see.
online class. Online classes are like
Okay. Okay, good. Arad, last time in the first chapter, as you remember, we talked about solutions to quadratic equations, right? We learned some different methods to solve quadratic equations. The first method was factorization method. And after that, we studied how to solve quadratic equations by completing the square methods. And using this technique, we generated a formula, right? And after that, also we practiced how to solve quadratic equations using formula. That means that using formula, we can solve any quadratic equations. And after that, we actually practiced or solved a few word problems involving quadratic equations. Okay. And somehow you have some idea about quadratic equations. So now our chapter 2, Arad, is about indices, surds, and standard form. And that's also not so difficult chapter, not a big chapter. Maybe in 2 classes, I'll try to finish this. But you have to practice. But you do have to practice more and more questions if possible. As you understand more and more, also actually you will love learning math more and more. Because if you can solve, questions easily. When you read the problem, at the first glance, for example, if you have some idea, that means that your understanding skill, your analytical thinking skill actually has improved a lot. And after that, using this experience, you can also understand other subjects like chemistry or physics or statistics or biology, even other things much easier. Okay, because usually really students who are really good in math, they can learn other stuff much faster than other students. Okay, that's why what you are learning here now, it's not only about your this year, the grade 9, and this will help you a lot in the future when you go to grade 11, 12. After that, when you go to university, even after university in your career, it will help you a lot. That's why somehow you try to love what you're learning. Okay, practice as many questions as possible, and also at the same time, by solving and the different problems, you also improve your English. After all, English is not your first language. Okay, Ara, today we will talk about indices, surds, and standard form. So these are just details. You can read. Let's just read one by one quickly, and after that we will focus on this mathematical part. Can you read the first one, Arad?
use the concept and vocabulary of highest common factors, lowest common multiples. One second. Prime factorization, including using product notation and unique factorization theorem.
Okay.
Calculate with roots and with integers and fractional indices. Calculate with interrupt standard form a times 10n, where if a
Actually,
is
this should be 10 to the power n. Okay, I'll correct correct this. Okay, continue.
and where a is equal or more than 1 or less than 10 and n is an integer. Simplify and manipulate algebraic expression. Once again, simplify and manipulate algebraic expressions. Simplify expression using sums, product, and powers, including the law of indices. Calculate exactly with surds. Simplify surd expression involving squares and rational denominator.
Okay. Uh, Now, as you actually practice more and more, you'll understand what we are going to, what we are learning here. So, first, number one, we will talk about indices, or let's say exponents. So it has some properties: multiplication and division laws of indices, multiplication and division laws of indices, power law of indices, or that's the same thing, zero and negative indices. So these are the properties. Before we continue, moving to the next slide, let's just start with a definition. All right, actually in math, first we just give a definition, right? What number is it? We call this natural number, we call this integer, and after that we introduce some operations: addition of integers, subtraction of integers, multiplication. Okay, and in this way mathematics actually developed. Now we are going to talk about one thing here. Assume that we are given one real number. It's a real number. What's a real number? It's actually number on the number line, right? So actually, if you just draw on the number line, and this is zero, any number on the number line, we call this a real number. As simply, what is a real number? It is a rational number and the irrational number together. It gives us a real number. And what is a rational number? Any number that can be written in this form, right? We call this rational number. A and B are integers and B is not equal to zero. And how about irrational number? Any number which cannot be written like this, okay? Like, for example, for irrational number, pi is irrational number. Square root of 2 is irrational number. Square root of 3 is irrational number. How about for rational numbers? 1 over 2 is rational number. 3 is rational number. 2.1 is rational number. Together, they form a real number. And also, let's say we are given some positive integer. Positive integer. Okay? So now we are just going to define one thing, and everything we are going to learn here is based on this definition. And if you're given like a times dot dot a, let's say a number is multiplied by itself n times. Okay, so mathematicians, every time when they appear or when they actually have to use this kind of notation, okay, it's not so practical writing a lot of numbers multiplied together, right? So, and after that, they introduce a compact notation. How can we describe this product in a very simple way? And they introduce that thing. Okay, if a number is multiplied by itself n times, so we can just write it as a to the power of n. And here, this a, we call this base, and this n, we call this power, or index, or just exponents. They all mean the same thing here. Okay, so how do you read this? We just read it as a to the power of n. What does it mean? It means that a is multiplied by itself n times, right? For example, let's say here we have 10, 1000. How can I write this in a more simpler way? We know that 1000 is 10 times 10 times 10. So according to this definition, I can just write it as 10 cubed. How about if you have 1 million? 1 million, right? So we know that it's 10 times 10 times 10, 6, right? So actually I can just write 10 times 10 times 10 times 10 times 10 times 10. So how many tens are multiplied by itself? 6. So in a simple way, simply, or in a compact way, I can just write it as 10 to the power of 6. We have such numbers, right? For example, if you're measuring what is it? The radius of the Earth is a huge number. Writing all the digits is not so practical way. For example, if you're talking about the population of the world, right? It is 7-8 billion people, right? And how about the distance between the Earth and the Sun, for example? Now, what is the mass of the Earth, for example? And sometimes we have to use very big numbers, or sometimes we have to use very small numbers. And writing all the digits of those numbers is not so practical. But using this index notation, as you see that in very compact form, we can actually describe these numbers. Okay, that is the motivation of this story. And it has some properties. Number one is product a to the power m, a to the power of m times a to the power of n equals this. A to the power m divided a to the power n, blah, blah, blah. Okay, now here, let me just prove. Actually, you may memorize this, but you have to try to understand why here. Let's start with the first one. Why a to the power m of times a to the power of n is equal to a to the power of m plus n. And here, m and n, these are positive integers because n and m and n be positive integers. In general, also it is true actually, but here we are assuming that they are positive integers. According to this definition, a to the power m times a to the power n. What does this a to the power m mean? That means that a is multiplied by itself how many times? M times. Times, here we have times, and a times dot dot a, and here we have n more a's, right? Now here I have m a's, here I have n a's. Again, by definition, altogether how many a's we have? M plus n. So I can just write it as a to the power of m plus n. That is a proof of the first one. In similar way, we can prove the second one. Here, a to the power m to the power of m is divided by a to the power of n, right? Here we have something like this, a to the power of m over a to the power of n. So here we have a dot dot, here we have a over a dot a. How many a's we have? Here we have n a's. And how about here? Here we have m a's, right? And we know that this is a fraction, common factor. We can cancel them out, cancel them out, cancel them out. And here, if n is less than m, and how many a's will be canceled here? N a's, right? So here altogether, how many a's left then? It is m minus n. It's like, for example, let's say a to the power of 5, not a, okay, a to the power of 5 over a squared. In the denominator, we have numerator, we have a times a times a times a times a. In the denominator, we have a times a. So these two things, they cancel each other, right? How many a's left? It is a cubed, which is a to the power of 5 minus 2. Hello, Arat, are you there?
Yes, now I can hear.
Okay. Yeah, because small internet connection problem. Now we are back. Okay, Arat, in this way, also here, the third one, a to the power of m, the third one, a to the power of n. And what does it mean actually? It means that here we have a to the power m times a to the power m times dot dot a to the power m. Here, because here we have n, right? And how many a to the power of m's we have here? N. So by definition, again, it is a to the power of m times n. All right. Here we have also division, and these rules, we'll see them in the examples. These questions are really easy, okay? Just warm up. You just tell me, if possible, keep your microphone on, okay? Don't unmute it. So just tell me, let's do them quickly because these are just warm up and easy questions. And later we'll solve a little bit more complicated questions. So what is a squared times a cubed? Simplify.
A to the power of 5.
A to the power of 5. And how about this? A to the power of 5 times a to the power of 2.
A to the power of 7.
Okay. Next, Simplify each of the following. We are just using multiplication law of indices. Here, 4 to the power of 5 times 4 to the power of 6. What is it?
4 to the power of 11.
11. Here we have 8 to the power of
9.
9. How about C?
30 x to the power of 6.
Okay. D?
X to the power of 9 times y to the power of 7.
Very good. E?
12 h to the power of 8 times I mean k to the power of 9.
Very good. How about division? We should subtract, right? Bases are the same. So here we have A
8 to 3, a to 4.
to the power of 4. All right, simplify each of the following.
8 to the power of 7,
Okay,
x to the power of 4,
okay,
3 times h to the power of 4,
okay.
x squared to the power times y to the power of 4.
Very good. And power law of indices. What is A? A cubed
a to the
squared.
power of a to the power of 6 or a to the power of 8.
Very good. Simplify each of the following, giving your answer in index form. Okay, equals,
3 to the power of 8
are you sure?
is 16, so 16.
16, okay,
X to the power of 15,
all right,
3 times x to the power of 37,
all right.
and then is
In this question, first, we need to show one more step, right? Okay, first, let's just remove the brackets. Here we have x to the power of
28,
is divided by x to the power of
6,
6. That's equal to x to the power of
22.
22. Okay. Express each of the following as a power of a single number. So A,
6 to the power of 3.
okay,
20,
B,
72 to the power of 2.
okay. Express each of the following as a power of a single number. A,
9 over 25.
no. Express each of the following as a power of single number, right?
And
So,
3 over 5 squared.
okay, B,
4 over 7 to the power of 3.
cubed. Simply, we can say cubed. All right, simplify each of the following. Let's start with A,
64, A 6, B 3.
6,
A 9,
4,
sorry.
A to the power of 9, and B
B,
cubed. How about
yes.
B?
4 x squared y to the power of 4.
Okay. How about C?
C 2 times, sorry, 16 times A to the power of 17, B to the power of 15.
B to the power of
15, 15.
15. Okay, good. 0 and negative indices. And also here, all right, before we continue, let me just give a note here.
All of them are 1.
So we know
Out
that
of
if you just pick any number, right, that's not equal to 0. And we know that a to the power of 0 is equal to 1. And can you prove this? Why a to the power of 0 equals 1, Arat?
because like you have x to the power of 2 is mean x times x. X to the power of 1 is mean only x, but always there is 1 is mean like x squared is mean 1 times x times x, like x to the power of 3 is 1 times x times x times x, but this time is just only 1 alone.
Arad, can you write on the screen, like annotate, click on annotate? Can you prove this? The question is here, let's say a to the power of 0. Okay, this is a question. Prove it. Prove it. Okay. Also different idea. Good. Arad, now can you delete it? Can you erase it? Okay. So usually Arad also is fine, but usually how do you prove this? In the actually properties, in the order, it comes after this. We know that a is the power of m over a is the power of n. What is this? We have already proved that that's equal to a is the power of m minus n. Now let's just consider this case. What happened if m equals n? Because here we don't have any condition for m and n, right? They can be any number. At the same time, also they can be equal to each other. What happens this? At the time, here we have a to the power of m over, since n equals m, instead of n, we can write m. A to the power of m. On the right hand side, we have a to the power of m minus m. And we know that if you divide any non-zero number by itself in algebra, here is equal to 1. And how about here on the right hand side? A is the power of m minus m, that's equal to 0. So that means that a is the power of 0 is always equal to 1, where a is not equal to 0. Okay? That is one proof. Also in this way you can prove this. That's a more mathematical way. Using this one, and here is equal to 1, that's equal to 1. And k is the power of 0. Here assuming that k is not equal to 0. So that's equal to 1, that's equal to 1. And how about this? That's equal to 5, right? 5 times x to the power of 0, that's equal to 1, that's equal to 5. Okay.
Teacher, why we cannot divide 0 by itself?
Sorry?
Why we cannot divide 0 by itself?
You mean 0 over 0?
Yes, why we can't?
Can we?
No, I mean why we can't?
Yeah, I'm also asking, do you think we can?
No.
Okay. Here, actually, it depends on what is the 0. If it is exactly 0, now I ask you because when you are defining, things, we just define what is a plus b, what is a minus b, what is a times b, right? Let's say if you define something, for example, let's say is equal to something here, k, right? Assume that we can divide 0 by 0. Now again, using algebra, if you multiply both sides by 0, I have something here. 0 times 0 over 0 equals k times 0, right? And 0, 0 cancels each other. And what do we have here? Here we have 0 is equal to 0. What does it mean? What does it mean here? Always actually we have 0 here, right? Whatever you substitute here, you'll have 0. It doesn't, actually this 0 over 0, it doesn't give us any contribution. It's no application. All right. And that's why such division is not defined. Or even if you define, how do you define this? Okay. And you may wonder, how about very small numbers close to 0 and close to 0? At that time, we need to learn a bit more advanced math. And this kind of division, actually, we study in calculus. At the time, we have to use this limits, okay, limit of something when actually that is 0 and what this thing is 0. And depending on the type of function, actually they have different values. The 0 over 0, it may be equal to 1, it may be equal to something different. Okay, and that's why in school level we just accept that 0 over 0 is not defined. We don't have such division. Okay, all right. In more advanced math, you will see in the future.
No, I
Okay.
meant completely zero.
Huh?
Because nothing, just I meant completely zero. Which I answered.
Completely zero?
And nothing.
Yeah, here, for example, what do you think? If you were, for example, let's say 0 over 0, what do you think, for example, what must be the result of dividing 0 by 0, for example? Is it equal to 1 or what?
Because every number divided by itself is one, I think. But at the
Okay.
same time, it's zero as well.
Okay, you are saying that this one is 1, right?
No, one or zero.
But one division, it must produce only one answer. You should say is equal to
No,
0 or 1.
no, because it's undefined, I guess, like maybe it can be zero or one.
Yeah, that's why. That's why it's not defined, Because when I just say here 2 plus 3, what is it? It is 5, right? Now you can say that the 2 plus 3 maybe 5, maybe 6. We cannot say that. If you say exactly, for example, the 0 over 0 equals something, if you prove it, we would accept. So we cannot say that 0 is divided by 0 equals what? We cannot say exactly is equal to 1 or 0 what? I mean, if you just think you cannot give any number, whatever you just give here, that contradicts other algebraic rules. That's why it's not defined. We just accept this as we don't have such definition. Okay? And Arats, my idea is maybe in the future, now if I say mobile phone, do you know about mobile phone?
You mean normal?
Mobile phone, right? Smartphone,
Yes,
do you know, right? If I say internet, now we are using Zoom, right? But if I ask
yes.
the same question like 100 years ago, do you think people would understand laptop? Okay, the schoolboy and ask, what is laptop? What are you talking about? Internet, what is that? They don't mean anything for them because it didn't exist at this time. Maybe right now, 0 over 0, for us, it is meaningless. Maybe in the future, it can be defined in some different way. We don't know. But right now, it's not defined yet. Okay.
Okay.
All right. So a similar way, here we have negative indices, Arats. In a similar way, we can also show that a to the power of negative n is equal to 1 over a to the power of n. And how do you prove that? Again, I'm just using this property again. A to the power of m over a to the power of n. That's equal to a to the power of m minus n. Here, m and n, any number, right? Any integer, positive, non-negative integer. Now, if I take, for example, let's say m equals 0. What happens here? Here we have a to the power of 0 over a to the power n. On the right-hand side, a to the power of 0 minus n. Now, if you simplify this, what we get here? We have just proved that a to the power of 0 is 1. 1 over a to the power of n. On the right-hand side, 0 minus n, that is a to the power of minus n. So a to the power of minus n is equal to 1 over a to the power of n. In general, if you have a fraction a over b to the power of negative n, that's equal to b over a to the power of n. Okay, so using this, simplify. For example, here, what is a? That's just equal to a to the power of 2 minus 4. That's equal to a to the power of negative 2. Or that's just equal to 1 over a squared. And how about b? A to the power of 4 minus 7, which is equal to a to the power of minus 3. Or that's just equal to 1 over a cubed. Okay, all right, it's your turn. Simplify question A
A to the power of negative 3.
equals a to the power of negative 3. B,
B is A to the power of negative 5.
are you sure?
Yes. And
B
no, a
again.
to the power of negative 9. A to the power of
Negative
negative.
9. That's correct. And how about C? First, let's just simplify it. After that, it will simplify this. Let's remove the brackets first. Here we have A, 2 times negative 5 minus
Negative.
10, right? Here we have A is the power of 4, B is the power of 4, and here we have A to the power of negative 2, B squared. And in the question, it says that in positive indices only. We didn't read this part. So this A would be 1 over A cubed. And B will be 1 over A to the power of 9. And how about C? First simplify, and after that we will leave our answer in positive index.
B is equal okay, A becomes at the top negative 8, then it times that, so it becomes negative 4,
No,
B
no.
squared.
Okay. So here A, let's just tell me what is A to the power of
How
what?
should I say the answer? Or should I give the solution?
No, just tell me the answer. Simplify
B
A.
squared, B squared over A to the power of 4.
What? A squared?
B squared to the numerator will be B squared, denominator will be A to the power of 4.
Okay. So this B squared over A to the
A
power of 4.
4. This one.
Okay, good. Okay, I will skip these questions, and also let's just do only two of them. Uh, let's do C and D.
Teacher, it went. C and D.
D,
It will be 9 over 4.
9 over 4, right? D,
D will be again.
let's simplify first. And here we have, what is it? 3 to the power of
Negative 6 and 3 to the power of negative 12.
negative or positive?
Negative.
Are you sure? Because
No.
minus 3 minus 3 is plus 6, right? And
Yes.
9 is 3 squared, so it is positive 12. So which is equal to 3 to the power of 6. Okay. And fractional indices. And also, I think you know about fractional indices. Sometimes if you have a fraction like a to the power of m over n, right? And here n is positive. So we can just write it as nth root of a to the power of n. Actually, these two things are equal. Sometimes I can just write as a to the power of m over n, or nth root of a to the power of m. So that's how we define these two things. So here a, what is it? Rewrite each of the following in the radical form and evaluate the results. So first we have
2
to write in radical form, right? And evaluate the result. 4 to the
then
power of 2, it is
square of 4 then equals 2
b.
is equal to 1 over 20, root of 3 of 1 over 27,
So
which
that's
is
equal
equal
to,
to 1 over 3.
okay. And c,
60, I mean, third root of 64, which is equal to
cube
4.
root of 8 squared, right? And let's simplify this. It is
4
64. So that's equal to 4. And how about d?
is equal to is equal to square root of 1 million, I think.
100 cube, right? Or that's equal
Yes,
to square root of, let's say, 10 to the power of 6, and that's
which
equal to
is
6 over
1000.
2, 1000. Okay. All right, let's have break for 3 minutes, okay? Let's drink some water, and after that, we will continue a bit more and finish the class, okay?
Okay.
3-minute break.